This is the fourth in a series of videos on graphing polynomials by hand. And what we're doing is we're simply going through the steps of graphing a polynomial by hand. The first step is find the leading term, This was video part 2, part 3, and now we're here on part 4. We're finding the X intercepts, or the real zeros. We could also find the Y-intercept. That's kind of an optional statement. So let's look at see what we mean here. Well, the key is to find an X-intercept, you simply set y equals to 0. So let's look at a simple example. The simple examples is when they're written in factored form. So this would be, for example, minus 2x, x plus 4 squared, x minus 7. If it's written in factored form, to find the zeros, you simply set each individual term to 0. So how do you do that? Well, first you go minus 2x equals 0, x plus 4 is equal to 0, x minus 7 is equal to 0. And you simply solve each one of these. Here you divide by negative 2, so x is 0. Here you subtract 4, so x is minus 4. And here you add 7 to both sides. So here you have 3 distinct zeros, but we also have this concept of multiplicity of zeros. And the multiplicity of zeros is how many times each zero is a 0. So let's look at this one. Actually, let's look at minus 4 first. If you look at x minus 4, here is where it's a 0, right? But this is x plus 4 squared. So this is really minus 2x, x plus 4, x plus 4, x minus 7. It shows up twice. So the multiplicity is 2. Let's look at the 7. The 7 is due to this term right here, x minus 7. Now how many times does this x minus 7 term show up? Just once. So the multiplicity is 1. What about this x here? Here it only shows up once, so the multiplicity is 1. So if it's written in factored form, the finding the zeros is pretty straightforward. Let's do one more quick example. Let's do g to the x is minus 3x to the 4th, x plus 6, 2x minus 3. To find the zeros, you set each one of these equal to 0. So here you go, minus 3x to the 4th is equal to 0. X plus 6 is equal to 0. 2x minus 3 is equal to 0. You solve here, you divide by a negative 3, and you get x4 is equal to 0. Take the 4th root, you just get 0. Here, you're going to subtract 6 from both sides. Here, you're first going to add 3. And then you're going to divide by 2. So it's x is 3 divided by 2. I'm going to make sure I got the signs right. This is a negative 3, so I add 3, so it's a positive 3. And I did. So here are my zeros. 0, minus 6, and 3 halves. Let's look at the multiplicity. The multiplicity, this shows out how many times. Well, let's look right there. If we look right here, this is really minus 3 times x times x times x times x times x plus 6 times 2x minus 3. If you notice, the x shows up 1, 2, 3, 4 times, so the multiplicity is 4. Here you have x is equal to minus 6, so you have it here. This only shows up once, so the multiplicity is 1. And then here you have 3 halves, so it only shows up once, and there's the multiplicity. So that's if it's in factored form. Now what if it's not in factored form? If it's not in factored form, then you have a couple of options. And probably the most common thing to do is factor it. Often you use what's called factor by grouping. And sometimes you just use regular AC factoring or difference of squares, etc. If you look again at, if you need help with factoring, then again, just go to MA class notes and there's a series of problems. Probably the ones you want to look at are factor by grouping, factoring squares, or there's another one, factor ax to the fourth plus bx squared plus c. And there's some other videos that will be helpful as well. Sometimes you even need to use quadratic formula, though in the simpler examples you won't need to. Let's do a quick example of this. Let's say you had g of x is equal to x to the fourth minus, let's do minus 40 plus 6x squared. Well, first I need to factor that, and that factors, if I substitute in y is equal to x squared, I get y squared plus 6y minus 40, and this becomes a simple factoring problem. Y, I think it's a positive negative, I think it's a positive 10 and a negative 4. Let's see if that works. 10 times negative 4 is negative 40, 10 times, that works. And now let's think about it. Y is x squared, so this is really x squared plus 10, x squared minus 4. We notice here we're just using what we learned in the video, factoring ax4 plus bx squared plus c. Now we can use what we learned when factoring squares. This is going to be x plus root 10i, x minus root 10i, x plus 2, x minus 2. Now, an important thing to realize is if it's an imaginary number, it's not an x-intercept. So the only x-intercepts we're going to have are going to be a negative 2 and a positive 2. And the multiplicity of both is going to be 1 because they show up 1 each. So the only thing you have to remember about factoring and quadratic formula is if you're solving for the zeros and you get an imaginary number, then that is not an x-intercept. Anyway, that's step number 3, finding the x-intercepts. Finding the y-intercepts is very easy. What's true at the y-intercept? X is equal to 0. So now, if you look at any problem that's not in factor form, let's look at these two examples. In this example right here, if x is 0, then this is 0, and this is 0, and this is 0, and the y-intercept is 3. Let's look at another one. Let's look at k of x. 3x to the 5th plus 2x to the 4th plus 6x plus 11. To find the y-intercept, you set x equals 0. So that's a 0, 0, 0 plus 11, so the y-intercept is 11. So you don't need to find the y-intercept, but it's very easy. And then we're done.